Hello friends, today we will discuss about Gram-Schmidt orthonormalization process. First of all, we should know about what is Gram-Schmidt orthonormalization process. The Gram-Schmidt orthonormalization process is a method for converting a set of vectors into the set of orthonormal vectors. Here we have the set of vectors v1, v2 and v3. So after Gram-Schmidt orthonormalization process, we have to convert this u1, u2, u3 in orthonormal vectors. So orthonormal vectors we can represent u1, u2 and u3. So we have to convert in orthonormal vectors by using Gram-Schmidt orthonormalization process. Okay. So here in first column you can see 1, 2, 3 is first vector, 2, minus 1, 0 second vector, v3, 2 that is 1, 2, minus 5 is the third vector, that you can say column vectors. Okay. So here I have mentioned these three vectors. You can see here this is column vectors. So if I want to write this v1, it will be like 1, 2, 1, then v2, 2, minus 1, 0, 1, 2, minus 5, right? So this matrix we have to convert into the orthonormal vectors, orthonormal column vectors, right? So here what we need to find out, we need to find out u1, u2, u3. Okay. So we will be getting the new orthonormal vectors in new matrix. So the column vectors will be u1 and u2, u3. So here I kept here question mark. Okay. So this question mark means this we need to calculate. Okay. So what is our aim? Our aim is to calculate u1, u2, u3 vectors. That is column vectors of orthonormal. We can say orthonormal vectors. So here we have to form one new matrix, that is after GSO process. So here we have to find out this question mark means this 3 cross 3 matrix elements, right? So what is the u1 and what is u2 and what is u3? How to calculate this u1 and how to calculate this u2 and how to calculate this u3, right? So here you can see we need to calculate u1, u2 and u3. So step 1, you need to remember like how to find out this u1 and what is the equations. So here I have mentioned the equations. u1 will be v1 divided by v1 modulus. Okay. So here v1 we will be knowing v1 we have taken from the A matrix, that is the first column vectors, that is we can see 1 to 1, that is first column vectors of A matrix 1 to 1. Okay. So we use this one, we kept this 1 to 1 value here because that is column vectors v1 of A matrix, right? And how to calculate modulus of v1, that is here I have mentioned the formula like x square plus y square plus z square. So these are the elements of the vectors, right? X square, y square and z square. So here 1 square, this 1 square, 2 square and 1 square. So this will be root 6, right? So you can see here u1 will be 1 by root 6 because this 1 is there, 1 by root 6. Okay. Then 2 by root 6. So we have separated this column vectors, right? 1 by root 6, 2 by root 6, 1 by root 6. Okay. So here you can see u1. So now we have calculated u1 vectors till now. Now step 2 is we need to calculate the u2, right? So how to calculate the u1? You remember this formula again. u1, u2, we have to calculate the u2. That is the formula here I have mentioned. u2 will be omega 2 vector and modulus of omega 2, right? So that is the formula for u2. So again, what is that omega 2? This vectors we need to calculate. So I have mentioned this formula for omega 2. So what is that omega 2? We will calculate omega 2 is v2 minus u1 vectors that we have identified in previous step, like step 1. Then u2 is the column vectors of A matrix, first matrix that we are using. So that is second column, this u2. Then u1 is again what we calculated in step 1, right? So we will put all the values here and we will calculate this omega 2 vectors, that is our orthonormal vectors. So we have to put all the values, and you can see I have mentioned, I have kept all the values of v2 and u1 and v2 and u1. So v2 is the second column vectors of first matrix. This is v2, and u1 is that what we calculated in the step 1. Again this u2 is our first column vectors of first matrix, a matrix, and u1 that we have calculated the step 1, right? So I kept this value, and we have to solve this. So if you are solving any matrix, firstly you solve the dot product. So here we have the dot product, this one u1, here we have the dot product, this u1 dot v2. So if two vectors is there, a1 a and a dot b, so we have to calculate a1 b1 plus a2 b2 plus a3 b3. So here like a column vector is 1 2 3, then b is 3 4 5. So here you can see this is a1, this means this is a1, this is a2, this is a3, this is b1, this is b2 and b3. Okay, so how to multiply? A1 means 1 multiply 3, 2 plus 2 multiply 4 plus 3 multiply by 5, right? So here we have to get, so after this we will get the scalar quantity after solution this. So we have to solve this dot product u1 dot v2, right? So let me solve this, and once we will keep all the value, so step by step I have solved this. 1 by root 6 multiply by 2. Okay, so multiply by 2 we kept here, plus, okay, plus 2 by root 6 multiply by minus 1, so multiply by minus 1, then plus 1 by root 6, this third element, and third element of second vector, so 0. So this will become 0, right? And this also minus, this is plus, so root 2 by 6 minus, because this minus will come here front, so minus 2 by root 6. So this and this also will be 0. So what our new vectors here we got, our new vectors after multiplying we will get 0, 0 only, because 0 plus 0, so yeah, minus 0 plus 0, right? So here this will be automatically 0. So we once, if we will multiply this 0 with this vector, that is our u1, this is u1. So if we will multiply with 0, this will be 0 only. So what omega 2 vectors we got the 2 minus 1, because here minus is there now, minus 0, so 2 minus 1 and 0. Okay, and minus 0 means nothing. So what we got the omega 2 vectors, we got the omega 2 vectors 2 minus 1 0, right? So I hope you understood like how to calculate this omega 2 value, right? Then here we calculated this omega 2 value, right? But still our u2 vector, that is orthonormal vectors, is remaining. So what is that formula for that vectors? Means if you want to calculate this u2 vectors, okay, so that will be omega 2 and modulus of omega 2 vectors, right? So this is the formula for u2. So now we have calculated this omega 2. Here you can see, here omega 2 value we calculated, that will be 2 minus 1 0. Okay, so omega 2 value we calculated, right? Now we put the value of omega 2 in the step 2 to calculate the omega 2. So okay, I have mentioned omega 2 vector and fraction of by omega 2, modulus of omega 2, right? This we have to solve. So here we already got this omega 2 value. What is that omega 2 value? We got that omega 2 value 2 minus 1 0, 2 minus 1 0. So here I have mentioned 2 minus 1 0. And how to find out this modulus of omega 2? So we can calculate x square plus y square plus z square. So what is first value? 2 square plus minus 1 chi square, that is 1, plus here 0 actually. So 0 square means 0 only. 2 square plus 1, 4 plus 1 5, right? So what our u2 value will be, u2 vector, that is orthonormal vector, it will be 2 divided by root 5 comma minus 1 divided by root 5 and 0 by root 5, that will be 0 only, right? So this will be our second vector of the orthonormalization matrix, like GSO matrix. So second vector we go 2 by root 5, 1 by minus 1 by root 5 and 0, right? So I have solution step by step. You can see here, this is both are matching, means we calculated our second vectors by using the Gram-Schmidt orthonormalization process, right? Now what is our next aim? Next aim is to calculate the u3, right? So again u3 formula is, you can remember, omega 3 divided by modulus of omega 3. You remember this formula. So we can calculate the third orthonormal vectors, right? So we have to calculate this u3. And how to calculate this u3? Again we need to calculate the omega 3 value and modulus of omega 3 value. Okay, so we will solve this, and you must remember here what is the formula for omega 3. So here I have mentioned the formula for omega 3. Okay, so what is that? Omega 3 is this one. V3, that is our A matrix was there. So there we have the some columns like whatever. So here I have the first, second vector, third vector. So this is the our third vector. U1, that is our first value, and V3 is the third vector again, and U1 our first vectors of orthonormal matrix, right? So here I will show you the all the values that we calculated, and very recently in the step 2 we calculated U2, that is 1 minus 2 0, not 1 minus 2 0. I will show you that what we calculated. Here is the first value. This is the A matrix, you can say. I will write here A matrix means 1. This is column vector, so 1 to 1, 2 minus 1 0, and 1 2 minus 5, that is our matrix. So here U3 value is last column, right? And V1 is this one, that is V1, this is V3, and this is V2, right? So you easily you can understand it, what is V1, what is V2, what is V3, right? Now we have to put the value of U1, that is step 1, okay, and this is we got from step 2, right? So we will put all the values. I have also mentioned the what we calculated in previous. V1 we calculate 1 by root 6, comma 2 by root 6, 1 by root 6, okay, and U2 also we calculated this value. So all the value we will put in these equations, and we will calculate the omega 3 vectors. So once we will put, this is one you can see this is V3, right? So where is the V3? Here you can see this is V3, 1 2 minus 5. So 1 2 minus 5 I kept, okay. Then U1, so we calculated U1, that is 1 by root 6 from step 1, 2 by root 6, 1 by root 6. So I kept as it is here, and V3 is the third column vectors. So V3 here, what is that? 1 2 minus 5, 1 2 minus 5 I kept, multiply with U1 vectors from step 1, okay. So I will put the U1 value, this is the U1 value I kept here, minus U2 second column vectors, dot V3 third column vectors of matrix A, so that I also kept. What is the U3? 1 2 minus 5, so 1 2 minus 5, here you can see 1 2 minus 5, and I kept here 1 2 minus 5, you can see this is our U2 V3, sorry. Then multiply with U3, that is second column vectors of orthonormal matrix, right? So that we have calculated in the step 2. So I kept this value here, right? And this is U2, you can see, you can match. So we will solve this. So if first of all, if you want to solve this such typical equations, what we will do, first of all we have to calculate the dot product. So if I told already, if A and B vectors is there, so how to multiply A dot B vectors? If A is 1 2 3 and B is 3 4 5, so how to multiply? It will be A1 B1 plus A2 B2 plus A3 B3. So means 1 multiply 3 plus 2 multiply 1 multiply 3 plus 2 multiply with 4, 2 multiply with 4 plus 3 multiply with 5 plus 3 multiply with 5. So we can calculate the A dot B, that is dot product. Similar way we have to calculate this dot product of U1 dot V3. So this U1 dot V3, here you can see this is U1, this is V3, okay. So you see in the next step I have solved that. So here all the values I kept, and we have to do the dot product. So this this will be 1 by root 6 plus 1 by root 6 plus 2 by root 6 minus 5 by root 6. So this will be 2 into 2, this will be 4 by root 6, and minus 5 by 5 by root 6. So 1 plus 4 5, so we can cancel this. So this will be the plus, means plus it will be 0. So 0, if you want to multiply with this, it will become 0. Similar way for this also, 2 multiply 1, that is 2, and this is minus 2, already is there, 0 is there, that will be this will be cancelled. So 0 multiply with this vectors, it will be 0 only. So what we omega 3 value we got? Omega 3 value will be 1 2 minus 5, right? Now omega 3 we calculated, but still we not solved our matrix. We have to calculate the U3 value, that is omega 3 divided by modulus of omega 3, right? So how to calculate omega 3 modulus? We have to calculate x square plus y square plus z square. So here what we omega 3 value we got, you can see here, and we will put the value of omega 3 in this formula. So we can calculate the U3, right? What we can calculate? U3, this one. So you can see in the next step here finally what we will get, this will become 0, this will also will become 0, and finally we will get the 1 to minus 5. So I hope step by step solution for this, easily you can understand it. So what omega 3 value we got the omega 3 value, this one 1 to minus 5, right? So now you have to calculate the u3, that is omega 2 omega 3 sorry, and divide by modulus of omega 3. So we have to put the value, okay, and we will calculate the omega 3. So again I no need to explain this. Similar way we can calculate that what we solved in the last steps, previous step. So this will be 25, 5 square 25, right, and 2 square 4, 1 square 1, so 1 plus 4 5, 5 plus 5 20, 30. So this will be 1 by root 30, and 2 by root 30 minus 5 by root 30. So till now we have calculated all the u1 u2 3 values, right? So we have calculated this, and I have mentioned this what value we calculated, u1 u2 u3 we have calculated, that is the orthonormal vectors, okay. So after Gram-Schmidt orthonormalization process, we will get the new matrix putting the value of this column vectors u1 u2 and u3. So we will get the new matrix. This is our new matrix. So what this is the column vectors. So 1 by root 6, this 2 by root 6 and 1 by root 6, that is column vector. Then 2 by root 5, okay, here you can see second 2 by root 5, this is minus 1 by root 5, and this is 0, okay. Now similar way we kept this value of column 3. So 2 by 1 by root 3 I kept here, 2 by root 3 and minus 5 by root 3. So I hope you understood this. But what we calculated, whether this is correct, because 1 by root 5 once you will solve with calculator you will get this value, right? 2 by root 6 also you will get this value. So whether this is correct, how to verify this, whether this my calculation is purely correct solution or right? So what I did, I have written one MATLAB code to verify this matrix, whether this Gram-Schmidt orthonormalization process is correct. So we have to solve this, means we have to verify our solution. So I have written one MATLAB code, and you can see this is the MATLAB code. And if you want this MATLAB code, you can follow me on LinkedIn. There I will share this code with you, even the PPT also. So here we what we calculated, this is our new matrix. So this matrix we have to compare with our simulation, means coding result. So here you can see this is the MATLAB result, and here you can see this this is matching 0.4082, 0.8165, 0.4082. So our MATLAB code is also correct, and our solution is also correct, there is no doubt. So thank you for watching my video, and you can subscribe my YouTube channel, that is Tech Learning, and I will share the advanced machine learning algorithm in upcoming days. So thank you all, thank you so much. You can follow me also on LinkedIn. My name is Dr. Bansilal Berwa. You just type in the Google who is Dr. Bansilal Berwa, you will get the information about me. Thank you all.